Suppose limit f of x as x tends to a and limit g of x as x tends to a, both the limits exist and k is a constant, then limit of sum is what? Sum of limits. I have expressed result number 1 in words. Limit of sum of two functions is sum of limits of two functions. Secondly, limit of difference is what? Difference of limits. Number 3, limit of product is product of limits. Number 4, limit of quotient is limit of numerator upon limit of denominator. But note that denominator cannot be 0 for the function to be a real valued function, right? So limit of quotient is limit of numerator upon limit of denominator, provided limit of denominator is not equal to 0. Now result number 5 is very important. Limit of composite function. I have already told you that before you start studying limits, you should know about functions, composite function, inverse function, etc., trigonometry and logarithm. See, what is limit of f of g of x as x tends to a? It is f of limit of g of x as x tends to a. That is, first you have to find limit of which function? G of x as x tends to a. Suppose that value is k, then you have to find f of k. In particular, I have considered one of the two functions as logarithmic. So what is limit of log fx as x tends to a? It is log of limit of fx as x tends to a. You can remember this as limit of log is log of limit. I repeat this, limit of log is log of limit. So this result is again very important. Now some standard results. What is limit of constant as x tends to a? It is going to be k only. Now I'll tell you the reason for that. Can I write k as k into x raised to 0? Yes, I can. As x tends to a, this k into x raised to 0 will tend to what? K into a raised to 0. But clearly a raised to 0 is 1 if a is not equal to 0. So k into 1, that is k. In other words, as x approaches a, or for that matter x may approach any number, k remains k only. That is why it is called as constant. So limit of any constant is that constant only. Second, limit of sin x as x tends to a is sin a, and limit of cos x as x tends to a is nothing but cos a. So here to take the limit means to replace every x by its limiting value, which is nothing but a in this case. In particular, limit of sin x as x tends to 0 is what? Sin 0, which happens to be 0. You could have said limit of sin x as x tends to pi by 2 is what? Sin pi by 2, which is nothing but 1. Secondly, limit of cos x as x tends to 0 is cos 0, which is nothing but 1. You could have said limit of cos x as x tends to pi by 2 is cos pi by 2, which is nothing but 0. Dear friends, here I will ask you one question. I'll give 1 minute to think on this particular question and then I will tell you the solution. My question to you is, here I have generalized results for sin and cos. Can I say limit of tan x as x tends to a equal to tan a? I repeat the question. Here I have said that limit of sin x as x tends to a is sin a. Similarly, can I say that limit of tan x as x tends to a equal to tan a? If your answer is yes, you have to justify it. If you say no, still you have to justify. I'll give 1 minute. Okay. So what is your answer? The answer is no, not possible. Limit of tan x as x tends to a equal to tan a is not possible in all the cases. The reason is simple. Sin x and cos x, these functions are defined for all real values of a. So whatever may be the real value of a, the value of sin x at that real value of x is always defined. Is that clear? Same is true for cos x. But there are many real numbers for which tangent ratio is not defined. For example, tan pi by 2 is not defined. Is that clear? And that is why we cannot generalize the result limit of tan x as x tends to a equal to tan a. I hope you understood. Now, this is the first sum. Again, I'll give you some time. You try to find the solution and then I'll explain it. The sum is limit x square minus 9x plus 20 upon x square minus 6x plus 5. And what is the tending value of x? Tending value of x is 5. I'll give you 1 minute. Try the solution. Dear friends, when I give you some time to go through the solution, you won't be able to see me and you won't be able to hear me because I have given time to try the solution. Okay. Now, let us discuss the solution. Limit x square minus 9x plus 20 upon x square minus 6x plus 5 as x tends to 5. See, in the very first step, we should try to take the limit. Now, to take the limit means what? To take the limit means to replace every x by its limiting value, which in this case is 5. We go to the next page. Let us see what happens. This is the given sum. Can we take limit in the very first step? The answer is no. Let us verify. To take the limit means to replace every x by its limiting value, which in this case is 5. 5 square is 25. 25 plus 20, 45, less 9 into 5, 45. That is 0. So numerator is 0. It's fine. But denominator should not be 0. Let us see denominator. 5 square is 25 plus 5, 30. 30 minus 6 into 5, 30. 0. So we are getting 0 by 0 form, which is absurd. This is an indeterminate form in mathematics. So we cannot, though we wish, we cannot take limit in the very first step. Now, value of the polynomials, both in numerator and denominator, their values are 0 at x equal to 5. So the conclusion is x minus 5 must be the factor of both numerator and denominator. Why? We already discussed this. If value of the polynomial is 0 at x equal to 5, then x minus 5 is a factor of that polynomial. Dear friends, if we know one factor, second factor can be written by observation, right? See, x into which term is x square? X into x minus 5 into which number is plus 20? Minus 5 into minus 4 is plus 20. So by observation, we can get the second factor. What about denominator? In denominator also, the first factor is x minus 5. The second factor has to be x minus 1. Reason, minus 5 into minus 1 is nothing but plus 5. Now, can I cancel x minus 5? The answer is yes. Why? See, x only tends to 5. X is not equal to 5. And as x is not equal to 5, x minus 5 is not equal to 0. So, division by x minus 5 is defined, is valid. Now, many students, after cancelling this, they directly evaluate the limit. That is not the correct policy. After cancelling the common factor, in the next step, mention the remaining factors. They are x minus 4 in the numerator and x minus 1 in the denominator. Now, can we take the limit? The answer is yes. To take the limit means to replace every x by its limiting value. So, in the numerator, 5 minus 4, that is 1. In the denominator, 5 minus 1, that is 4. So, before that, I have used the result. That what is limit of quotient? It is limit of numerator upon limit of denominator. Now, you have to say evaluating the limit. So, 5 minus 4, that is 1. And the denominator, 5 minus 1, that is 4. So, what is the final answer? It is 1 by 4. Actually, it is better if you write final answer in this form, that L. What does L stand for? The given limit. So L is nothing but 1 by 4. See, you are not solving multiple choice questions, so method is very important.